All right, so far we have talked about volts and we've talked about current. Now, the last thing in our lesson today that we're going to talk about is resistance. This is something new. We've kind of mentioned it with our FET simulation, but resistance is basically when we are trying to slow or stop the flow of electrons. Okay, in other words, we want to slow or try to stop our current flow. Okay, because that's what current is, the flow of electrons. Now, I like to think of resistance when I think about somebody running track. Every time that somebody is running and they put a new hurdle in front of them, that slows them down a little bit. That's what resistance is doing, trying to slow it down. Now we measure we measure resistance in ohms. And you see this like little funky symbol right here? This is what we call the omega symbol. And this is what we normally use to represent ohms. So anytime you see this, we're actually talking about resistance or R here. Okay. Now please make sure in your notes that you put these letters as well as these larger letters out beside it, because that's going to help you with your math here in just a few minutes. Now, resistance can be a good or a bad thing, and you saw that in your reading. But resistance can be affected by many different things. We can actually lessen resistance by making the wire wider, or we can even shorten the wire. Okay, if we shorten it, that means there's less things for it to run into, less hurdles it's going to have to go around. Also, with wider, you have more room. Think about you guys in the hallway. The wider the hallway is, the more room you guys can move and the faster you can get through the halls. If we were to cut that hallway in half, you guys would have to be in a really, really tight, small space, and it would take longer to get you guys through the hall to the end door to your next class. So if we reverse that and we're talking about more resistance, if we want to slow our current down, we would have a thinner wire. That was kind of the example I gave you the hallway. Another thing you can think about is a water hose. If I bend or pinch a water hose, that's going to make it thinner, make it basically harder for the water to get through. So I'm increasing my resistance. When I let it go, the water can flow freely, making it wider, so lessening the resistance. Also, if I make the wire longer, I'm going to have more resistance. Now, resistance can also be affected by the temperature as well as the type of material that it is made out of. So there's lots of different things that can affect resistance, but pretty much anytime we have a circuit and you put an item in that circuit, whether it be a light bulb, whether it be a switch, or even a resistor to slow down the current, you're going to affect that current flow. And we saw that, like I said, in our FET simulation last week. Now, what we want to try to do is we want to try to use this VIR, or in other words, Ohm's law, to actually be able to calculate voltage, current, and resistance. Now, Ohm's law states that the current passing through a conductor is proportional to the voltage over the resistance. In other words, I, which is your current, is equal to the voltage divided by the resistance. Or we're going to use this middle one here. We're going to use multiplication. Voltage equals I multiplied by R. So voltage equals current times the resistance. Now, because there's only 3 variables here, we can use our triangle, which is awesome that you guys love. So here's our triangle already filled in. Yours is on page 40, but it's voltage equals I and R. We know that if it's over, we divide. If it's beside, we multiply. So let's start with this first one here. It says there is a 28 resistance ohms in a heating element. It's plugged into a 110 volt circuit. How much current passes through the heating element? What we can see here is I've already highlighted for is the current, because that's what we're looking for. So what we're going to do is we're going to come over here to our triangle and we're going to cover up I. And I'm going to use my mouse to kind of do this here. So that leaves us with V over R. So we're going to take our volts, which in this problem is 110, and we're going to divide that by our resistance. So our resistance is 28 ohms, or we can use our omega symbol. Now what this is going to give us is our amperage, or our current, which is 3.93. Now I rounded here amps. You're welcome to go an extra decimal place, but normally I'm going to tell you just round to the second decimal or the third decimal. place. But you notice that I put my units here. That's really important because we are dealing with 3 different variables. You must put your units. Now, a lamp operates at 115 volts with a current of 0.5 amps. What is the lamp's resistance? So once again, I'm going to highlight what I'm looking for. Okay, so we're looking for resistance, so I'm going to use my mouse. We're going to cover up the R. This time, we're going to take our volts and we're going to divide it by our I, which is our current, or our amps. So 115 volts divided by 0.45 amps. So if we're going to do this math here, it'd be 115 divided by 0.45. You should get around approximately 255.56. And because this is resistance, ohms. Instead of ohms, you could also write the omega symbol as well. So I could do this also. So you can kind of see it all together. I'll hit it down. Now you're going to continue to use this same formula, this same triangle, to answer questions 3 through 10. Okay? If you need any help, please feel free to email me. Make sure that you have your tip chart complete as well as your Venn diagram. Make sure you're able to compare and contrast these 3 things. I will try my best to answer any of your emails if you have any questions. I hope you guys have a wonderful day, and I look forward to seeing you guys back tomorrow.